Year 1 and welcome to our 5th day on addition and subtraction. Now, this is a bit different because we actually got 7 days of this work because it's quite an important skill. So, although this is going to look like day 5, we're going to be carrying on with it even more next week. Okay, so to start with, we have got our weekly arithmetic test. So if you want to have a go at these and note the halves that have crept in now, which we did before the holidays, and there's also some new stuff here as well that you only did for the first time last week. But remember, you can use whatever equipment you want. So you could be using the halving grids, you could be using 10 bars and ones here, you could be using a number square here. Okay, and when you're ready, we'll go through the answers. Okay, so we're now going to go through the answers. So 5 plus 7 makes 12, well done. 13 minus something makes 9, and that's going to be 4. 3 plus 10, so that would be start at 3, count on 10, or drop down 10 would be 13. 8 plus 8, that's a double, 16. 30 plus 20, you could use 3 10 bars and add 2 10 bars to give you 50, or you could drop down 2 on a 100 square. Half of 4 using your grids, that's going to be putting 2 in each side, so the answer is 2. 16 plus 8, 16 plus 4 is 20, plus another 4 is 24. 3 plus 10 plus 10, again on the number square you could start at 3, drop down 10, drop down another 10, 23. 26 equals 20 plus something, so that's splitting that, and that's going to be 6. 50 plus 10 is 5 10 bars plus 1 10 bar, or count on or drop down 1 from 10 to 60. Half of 6, 3. 24 plus 6 is 30. 3 plus 20 plus 20, that would be 2 jumps each time, is 43. 36 equals 30 plus 6. You see the way that we're separating 36 into the 30 and the 6. And the last one on this column, 50 minus 40, 10. And half of 20, that would be split in 2 10 bars, which will give you 10. 39 equals something plus 0, so that's going to be 39. 13 plus 10 plus 20 is going to be 43. And then 36 plus 20 equals 20 plus something. Well, that's going to be 40. That's going to be 16, sorry. And the last one, 60 minus 40 is 20. Brilliant work, year 1. Okay, so today we're going to be applying that commutative law to find addition and subtraction sentences like we did in the plenary yesterday. Okay, and these are the things you're going to be able to do. So let's get started. Okay, can you write as many number sentences as you can using this as a base? If you just want to do addition to start off with, that's brilliant. But if you can come up, think of some subtraction sentences as well, that's even better. So I'm going to do the first one now. You can pause it if you want, if you're confident, or you can pause it after I've done the first one. So the first one is going to be 8 plus 2, because that's the 8 green plus the 2 blue, equals 10. Okay, so you may pause it again now if you want. The next one we've got is 2 blue plus 8 green equals 10. And then we can turn these around. So 10, which is all of them, equals 8 plus 2. And then 10 also equals 2 plus 8. Now, subtraction. We start with how many there are on the grid. So that's 10. We subtract. If we subtract 8, which is the green, we take the green away, and that leaves 2. Okay, and then we can start looking at the patterns. So equals 8, because this time we've got the 10. We take away the 2 blue, and we end up with 8 green. And then the next two are simply turning the sums around. So we would have 10 minus 8, and that equals 2. It may be easier to write it like that. And then we've also got, start with the 8 green, we've got 10 altogether, and we take away 2, which is the blue. And those are all the possible number sentences you can make using that grid. So what you're going to be doing today, because I don't think you need many more examples of this, and if you want to use grids to help you, that's absolutely fine. What you're going to be doing today is this. These are the simpler options, and we're only looking at coming up with 4. And they're all facing the normal direction your grown-ups will be used to. Work out what the answers are, solve the first one, and then you will find that you should be able to solve the others based on that. Because the key with the commutative law is the numbers. There are only ever 3 different numbers in each sum, which forms a number family. Okay, if you think that's a bit easy, have a go at this. And this is essentially the same, but it's number bonds all the way to 20. And the last one is actually up to 30. So I'm going to give you 5 seconds to select which one. And then we've got a plenary to finish with. So that's choice 1. Pause if you want now. And here comes the slightly more challenging choice. Okay. And when you're ready, we'll go into the plenary. Okay. So, very quickly, can you find the answers to these questions? 2 plus 2, 2 plus 8, and 8 plus 2. Well, to help you, I'm going to put it out on a grid. So we've got 2 blue, and we've got the 8. 8 blue. So how many are there altogether? Right, it's a 10 array, so it's got to be 10. Okay. And using the commutative law now, we know the answer there is going to be 10. And then we've got 10, take away the blue, so what's left? The green, which is 8, and vice versa. Now, how else could we represent that? We use these in the first term, and we practice them in some of our arithmetics. Let's see if you can guess. Tell you're grown up, and I'm going to reveal. That's right, you can use a part-part whole. Now, what I want you to do is quickly figure out what the whole is and what the parts are until you're grown up. And when you're ready, I'm going to populate it. So, the whole has got to be 10. And the parts are the 2 different colours. So there's a 2 and there's an 8. Okay, now have a look at this one. I want you to solve and represent each of these sums using the part-part whole. Now in class we're doing this in 4 different groups, but you could do it each one yourself. So when you're ready, we'll get started. Okay, so 2 plus 8 we know is 10. 8 plus 2 we know is 10. 10 minus 8 we know is 2, and 10 minus 2 we know is 8. So if we were to look at the circles option, we would have 10. We'd have 2 in one of the parts, and we'd have 8 in one of the other parts. Now, if we were to do the rectangle, that's a bit weird. We'd have 10 as the whole. We'd have 8 as one of the parts, which we've got down here, and we've got 2 as the other part. What about the subtraction? Well, 10 this time is the whole. Well, it's still the whole. We take away 8, and it leaves 2 again. And do you know what? If we were to do the 10 minus 2 equals 8, we still would have the same part-part whole. And that is what we're going to be doing tomorrow. We are going to be using part-part wholes to make our own number sentences, because one part-part whole can generate all these different commutative rule sums. So that's the end of today's maths lesson. You've been brilliant.